a second part. So topics in theory of polynomial functions. And this is only part 1. So there's this first theorem called the intermediate value theorem. If you are going to go on and take calculus, intermediate value theorem, you learn even more about this. Very fundamental theorem. We abbreviate it IVT, intermediate value theorem. Okay. And so here's the idea behind it. I'll give you this graph, do a cubic function. Okay, so if I have a point A on my graph here and another point B, we'll say, then my P of A would be this point right here, P of A, which would be greater than 0. And my P of B would be down here. P of B would be less than 0. And in between these two, there lies a 0. Now, that's what the intermediate value theorem is really saying, that if I have a P of A function, if P of A and a P of B, so when I plug in a number A, and then I plug in another number B, and if those two numbers, those outputs are opposite signs, that's the key there. Then there has to exist a real 0 in between. Then there exists at least one real 0 between A and B. All right. If P of A and P of B, again, what am I talking about when I say P of A? I'm talking about the Y values when I plug in a number. Like if A was 2, I plug in P of 2, I'm finding out what's the Y value. And P of B, if they're opposite signs, one of them's positive, one of them's negative, then I must have a 0 in between. It must cross the x-axis in between A and B at least one time. Okay. So how do I show that? Like, what would be an example that they're going to do on homework tonight? It's going to say something like this. Use IVT, use intermediate value theorem to show, and they're going to give you a function, P of x, x cubed minus 2x squared minus x plus 1 has a 0 between 2 and 3. Okay, so you have to use IVT, intermediate value theorem, to show P of x equals x cubed minus 2x squared minus x plus 1 has to have a 0 in between. Okay, so you have to prove it using intermediate value theorem. So again, here's what the intermediate value theorem is. It doesn't matter. I'm going to let this guy be my A and this guy be my B. Okay, so I need to find the P of A or the P of 2. And then I need to find the P of B or the P of 3 in this case. And I got to see if they're opposite signs. If they're not opposite signs, then there's no 0 in between. So we plug 2 in. 2 cubed minus 2 times 2 squared minus 2 plus 1. Everywhere I see an x, I'm putting in a 2. And 2 cubed is 8. 4, negative 2, so that'd be 0. Negative 2 plus 1 would be negative 1. Okay, good. Now I'm going to plug 3 in. 3 cubed minus 2 times 3 squared minus 3 plus 1. Ugh, so let's see. I'm off tonight on my calculator skills. This is 27 minus 2 times 9 minus 3 plus 1. Yes, 7. Oh, okay. So they are different signs. They're opposite signs. Then there must exist at least one real zero. It must cross the x-axis in between 2 and 3 at one point. Now, I can look on my graphing calculator. I'm going to do it on my graphing calculator this time, and then I'll show it to you on Desmos just because I'm trying to learn Desmos myself. But you can go x to the third minus 2x squared minus x plus 1. Zoom 6 is your standard view. Give it a minute. There it goes. And look in there. So hopefully you can see the hash marks. It's hard to see, but I have 1, 2, 3. And look, between the 2 and the 3, it's crossing between the 2 and the 3. Neat. If I want to find that 0, it's actually not hard. The calculator is very easy about finding it too. You have to just do a sequence of numbers. You go to second, show you my finger, second, and then up here where it says trace, I call it calc, second calc. And then this list comes up right here, and you're going to go to 0. And then it's going to ask you 3 questions. You have to be left or underneath, in this case, the x-intercept, and then hit enter. Then move your cursor to be above the x-intercept. Hey, that's why it's a positive and negative, positive and negative. Hit enter, and then it says guess. Hit enter again. And it says 2.246. So my 0 is between negative, I have one, 2.246. Second calc 0. That would be my solution right there. Again, if I were putting this in the Desmos calculator, let's see if it, I think if I hit the home, yes. You hit that little home button, it goes to a nicer window. And so then I'll just type in x to the third power minus 2x squared minus x plus 1. And I think Desmos is nicer. It is. Wow, look at that. You put your cursor on it and look at that 2.247. You don't even need to type in extra stuff. I love this thing so much. Where were you back in my day? This is terrible. Oops, hit the wrong thing. All right, so anyway, there's how to do it on Desmos, and then there's how to do it using your calculator, intermediate value theorem. All right, now for some fun. Back when you were in, let's see, 4th grade maybe, and you learned how to do long division. Long division of polynomials. You're not going to love this. My students always hate this. I don't know why. It's not terrible if you remember your long division rules, which I'm actually going to give you an example of right now because I want us to go over the algorithm here. Let's do this. 604 divided by 23. Let's pretend you got a 4th grader and you got to help them learn how to divide. Okay, so here's what was the old way of doing long division, which works for polynomials. Chill out, Jack. So what you divide by goes on the outside, right? And you make your little division symbol and you put 604. And then what you really say is you look at these two numbers, 23, and you say, how does a 23 become a 60? What can I multiply 23 by? Just the first two, right? To become a 60. So I think 3 is too high because that would be 69. So 2 would be the best bet. And then you multiply 2 times 23. You don't have to write this down, by the way. I'm just showing you. It's 46. And then what do you do after that? You subtract. And 60 minus 46 is 14. And then you bring down. And then you do the thing. How many times will it be 23 to go into 144 this time? And it'll take 6 times. And you subtract. And then you get this number down here, which is your remainder. And what do you do with that remainder? Is you actually write it as a fraction. You write 6, your remainder, over what you divided by. And that is your answer. 26 and 6/23 is what 604 divided by 23 is. And that was annoying. You hated it. Well, good news, we get to do it with polynomials, okay? So we are going to divide. I don't have enough room on here, so I have to turn over. It's kind of bleeding through, so I have to get another piece of paper. Here we go. Okay, so you will have to divide 3x cubed minus 2x plus 5 by x minus 3. Did my dog move this? I think he did. So again, what you divide by goes on the outside. So you're dividing by x minus 3. That goes on the outside. And you put your little long division sign. Now here's the trick a lot of students forget. Your polynomial needs to go in descending order. And even if you're missing a degree, you need to put it in. So here's what I mean. So you have 3x cubed. That would go first. But do you notice you don't have a square term? You have to put in a placeholder. You call it 0x squared. And then you write your next degree, which would be x2x minus 2x. Then you put your number at the back. Okay, so you have to have that placeholder right there. Now here's how we do long division of polynomials. You look at this guy and this guy only. And you say, how does an x become a 3x cubed? What do I need to multiply an x to become a 3x cubed? Well, I definitely need a 3. And then I need an x squared. So I like to put it over here on top. Now, just like in division, once you got that number on top, you take this and you multiply it by the whole thing. 3x squared times x, 3x cubed. 3x squared times 3 is minus 9x squared. And then you subtract. Now, what I tell my students is I just changed all the bottom signs. So I go minus, plus, because that's what subtraction is. Subtraction is changing the next sign. And what should happen if you did it right, the front should cancel. Combine these together, you get 9x squared. And then drop down minus 2x. And then you do the whole process again. How does an x become a 9x squared? How does an x become a 9x squared? Well, I need a 9 and I need an x, and it needs to be positive. And then I multiply 9x times x, 9x squared. 9x times 3, 27x with a minus. Change a sign, change a sign. They will go away. Negative 2x plus 27x is 25x. Bring down. Again, look at the first term, look at the first term. How does an x become a 25x? I just need to multiply it by 25. So multiply 25 times x, 25x. 25 times negative 3 is negative 75. This is the part everybody forgets. Change a sign, change a sign. And you're left with 80. Now this is your remainder. And what you do is you write plus your remainder over your divisor, what you divided by. And that is your answer. Now I know what you're thinking. Please tell me we do not have to do this all the time. Well, there is a trick, and it's probably one of the best ones. It's called synthetic division, and it can only be used when you're dividing by something in the form of x minus a number. Like if it was 2x minus a number, you'd have to do other things. But if it's just like x minus 5 or x plus 2, you can do this synthetic division, which is what we're going to spend most of our time doing, because honestly, this is not fun. So I mean, I'm agreeing with you. Let's do this synthetic division. It's so much easier, and it's so quicker too. But the key here is you can only do it when you're dividing by an x minus k form. Okay, it's the only time you can do this. So if you look up here, we had this x minus 3 form. That is our k. Okay. Actually, our k is, we have to change the sign, which I think a lot of students always mess up. They think the k is -3. No, the k is, if it's already x minus, the k would be +3. So here is how I do division, synthetic division. You put your 3 out here, you change the sign, and I make an upside down L. You'll see why in a minute. The numbers that go next to 3 are the coefficients of the polynomial, but they have to be in order, and you have to include placeholders. I better write that down, actually. Include placeholders. Oh my goodness, you will get it so messed up if you don't include those placeholders. So 3 would go next. I have to have that 0 placeholder. Then a -2, and don't change any of these signs, just leave them like it is, and then a 5. So 3, 0, -2, and 5. Now, you might want to watch me do this first, and then we're going to do another one after this anyway, so that way you can kind of see what to do and then copy it down. So here's how you do synthetic division. You always drop this first one. Just drop it down, 3. Okay? Then you multiply these two together and put that number here. So 3 times 3 is 9. Put it here. And then you add 9. Multiply these two together, 27. Add these two, 25. Multiply 75. Add 80. This last number is your remainder. That's your remainder. These bottom numbers, look at what you got. Look, this is so cool. This 3, 9, 25 are the coefficients of a new polynomial decreased by 1 degree. So I originally had a degree 3. Now I have, this is 3x squared plus 9x plus 25. And then I would write my remainder, 80, and I'd put it over my divisor. And that is so much quicker. It was like boom, 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 boom. Multiply, put it here, add. Multiply, put it here, add. We're going to do another one because I think many of you were just copying or watching me do it, but that's the trick. It's just so much quicker. It's so much easier. Okay? Let me give you just a quick minute to write that down, and then we'll do another synthetic division. And the more you practice these, oh, the better you'll become at it, I promise. All right, so let's do one more. Let me pull this up. Let's do synthetic division on 5x cubed minus 6x squared minus 28x plus 8. And we're going to synthetically divide it by x plus 2. Okay? So now, notice this is not in the x minus k form. It's in the x plus form. So then what would be my k? My k would be this sign changed. Instead of positive 2, it's negative 2, because then minus and negative becomes positive. So my k is negative 2. So when I write my synthetic division, I put negative 2 here. Change the sign. Change sign. Give yourself little key phrases here. That's why I write them down. Okay, so now what goes here, here, and here? It's just all these coefficients. 5, negative 6. It's all in order, so I don't need any placeholders. And now the first number, you just drop it down, 5. Multiply, put it here, add. Multiply, put it here, add. Multiply, put it here, add. You just keep going, okay? Multiply, negative 10. Add, negative 16. Multiply, 32. Add, 4. Multiply, negative 8. Add, 0. Oh, I have a remainder of 0. What does that mean? That means that this went in evenly, huh? So then I now have, this was a cubic function, now it's a quadratic, now it's squared. So my answer is 5x squared minus 16x plus 4. I have no remainder. But this is important, and this is going to lead us up to our next theorem, okay? If that remainder is 0, then x plus 2 is a factor. When that was a 0, x plus 2, what I divided by was a factor. This is huge. This is way, way important, okay? This is known as the factor theorem. It's amazing. So let's write this down. We learned the IVT theorem. Now we learn the factor theorem. The factors theorem says that the polynomial p of x has a factor of x minus k, factor of x minus k, if and only if, that's what IFF stands for, p of k equals 0. If and only if you get out a remainder there of 0. The dog keeps moving my camera here. So they'll never say like use the factor theorem. They'll just ask you, is it a factor? Is it a factor of this? Is it a factor? So for example, one of the homework problems will say, determine if x minus 1 is a factor of, and then they'll give you this polynomial. P of x equals 2x to the 4th plus 3x squared minus 5x plus 7. Okay, see, they're not going to say use the factor theorem to determine. They're just going to say that keyword, is it a factor? Well, the factor theorem says if I get out a remainder of 0, then x minus k was a factor. Okay, so let's do this synthetic division again, because it's just so much easier to do. So here's my my binomial, x minus k. My k looks like my k would be 1, right? X minus 1, change the sign. So 1. Make my upside down. 2 would go first. Do I have a degree 3? No. Put a 0. Degree 2 is 3. Degree 1 is -5. And then my constant 7. Again, always, always, always drop it down. Multiply, put it here, add. Multiply, put it here, add. Multiply. Oops. You get the picture. So 1 times 2, 2. Add 2. 1 times 2, 2. Add 5. 1 times 5, 5. Add 0. 1 times 0, 0. Add 7. Now I don't have to write the polynomial. I just have to say, is it a factor? Well, this is not a remainder of 0. So then x minus 1 is not a factor. That has to be a 0 in order to say, oh yeah, it's a factor. It worked out. It was nice. It was even. It was beautiful. Okay? So that's the factor theorem. Then we have this other cool thing called the remainder theorem. Again, lots of theorems, but they just are so helpful. So helpful with polynomials. Okay? So here's the remainder theorem. And it says, if a polynomial, p of x, again, is divided by x minus k, the remainder is equal to p of k. If a polynomial p of x is divided by x minus k, the remainder is equal to p of k. So, what does this mean? This should blow your mind, because I wish that they would teach this like way in the beginning, because it's so much easier. But let me give you an example, and then I'll show you why this is so cool. So here's what they'll say. Again, they'll never say, use the remainder theorem. They'll write it like this. They'll say, hey, find p of -2, given p of x equals -x to the 4th plus 3x squared minus 4x minus 5. And then another question, is it a factor? Okay. Find p of -2 given p of x equals -1, x to the 4th plus 3x squared minus 4x minus 5. Okay, now, here's the old way that you would have done it. We'll call it old way. If you don't want to write it down, don't worry. I mean, that's fine, but I think this is neat to see. The old way, you would have done p of -2. How would you find p of -2? Well, you probably, everywhere I see an x, Mrs. said, I'll put a -2. Okay, negative of -2 to the 4th plus 3 times -2 squared minus 4 times -2 minus 5. Oh, this is, I mean, honestly, I don't want to begin this. I don't want to type it in. It just takes too long, and I'm already kind of like, oh, -2 to the 4th is 16, -16, I don't know, 4 times 3. I mean, I'm already tired. I just don't want to do it. Here's what the remainder theorem does. The remainder theorem uses synthetic division. This number right here that you're trying to plug in is your k. You don't have to change the sign. It's already k. It's already been changed. the remainder is equal to P of K. Huh? So do synthetic division. Again, I'm very fast at synthetic division. Write your coefficients. Let's see. So fourth would be -1. There is no cube, so 0. Squared is 3x, -5. And again, this is just much quicker for me. Drop it down, multiply is 2, add 2, -4, -1, 2, -2, 4, -1. Huh. My remainder, let me read this again for you. This is the key right here. The remainder is equal to P of K. P of -2 is that remainder right there. If I had done all this, I mean, and really worked it out, oh, let's see, then this would be -4 plus 8 minus 5. That would be 4 minus 5 is -1. You mean instead of having to plug it in and chug stuff out and work it all the way, I could just do synthetic division? My remainder is my answer as if I had plugged it in. That is awesome. That is P of -2. You just can do synthetic division and it works. Now, wait a second. Let's go back. Is this a factor, though? Is -2 a factor? No. Why no? Because this must be 0. This remainder must be 0. So this is not, let's write this down, not a factor. Because it's not 0. Or it's not equal to 0. Okay? But that saves so much time. Oh, you have no idea. No idea. All right. I have one more problem to show you. And this is where it all comes together. This is where I kind of geek out on this because this is like, no way. This is what all that we've been learning kind of leads up to. This last question right here, given. And you're going to do, I'm just going to forewarn you, you do have a few of these. I won't say few. Maybe 2 or 3 to do on the midterm and showing all work. And you're going to use all these theorems to try to do it. So given a function, P of x equals 2x cubed plus 5x squared minus x minus 6, okay? I want us to find the zeros and write P of x in a factored form with all the linear factors. Pretty much I want you to factor this. Find the zeros. And write P of x in a factored form with all linear factors. Linear meaning degree 1. Okay, this will be the last question we do. It's pretty easy. Okay. So the first thing I would do is I need to find the zeros. Okay. So what do we say zeros were? Zeros were x-intercepts. So let's go on my handy dandy calculator here. Again, you could put this in to Desmos. I'm just going to use my calculator. I'm going to type in 2x to the third plus 5x squared minus x minus 6. Okay, just look at the graph of it. Let me just see what it looks like and see if I have a 0 here anywhere. Oh, it looks like I got a couple zeros. I definitely got one at 1. And I didn't really see it go. I know it went up and down through it. I just not sure. What you could do is you could go to the table set or the table. Excuse me. Ooh, my table is high up there. Let me start my table again. So second table set. Let me start at 1. And let me go to my table. And I'm looking for zeros. There's 1 0. There's a 0. There's another 0. So I missed it. It was -2, 0. And again, you can see this on Desmos if you want to. But I'm going to write them out. So step number 1, plug it into your calculator and get a 0. At least 1. But we've already gotten 2, so we'll use both of them. Which was a 0? -2 was a 0, and then 1 was a 0. So so far I found 2 zeros. What's the most amount of zeros that I can have? What's the most? 3. 3 is the most. So this could be it, but 3 would be the most. Okay, so we found some zeros. Now you're going to use these zeros and you're going to do synthetic division with these zeros. This is super cool, okay? So you're going to do synthetic division. So here's what I mean. You're going to take, I'll just take that first one, -2. And you're going to synthetically divide it into your polynomial. 2, 5, -1, and -6. 2, 5, -1, -6. I better get a 0 down here because it is a 0, so it better work. So let's see. 2, -4, 1, -2, -3, +6, 0. Okay, whew, I did it right. Yay. Okay. Now, again, what have I just created? Well, I've created a new polynomial. And it's now down by degree 1, 2x squared plus x minus 3. Well, what you could do now is take your second 0, not the -2, you already divided by it. Take your second 0, 1, and divide that into this guy. If you go back to the original, it'll get a little tricky. You will probably get that -2 out again. So that's why if you just divide it into the one that remains, the new polynomial. The new polynomial. And notice I'm not changing these signs because I didn't write it in a factored form. These are already, signs are changed, so you just leave it as 1. So I'm going to put a 2 here, a 1, and a -3. And again, I drop it down, multiply, add, multiply, and look at that. Now what would be this new polynomial? Well, this was degree 2. This would be degree 1. And what I've just done, this is so cool. I'm geeking out on this. I have found a linear factor, one of them, 2x plus 3. I'm going to put it in parentheses. My other linear factors would be in the form of x minus k, x minus k, x minus k. What were the k's? Those were the two numbers I divided by. X minus 1, and then x minus -2, or x plus 2. Guys, that is the factored form of p of x up there. If I said, hey, factor that, that's the factored form right there. Now, if I asked you, what are all the zeros? Well, now it's easy to read real quick. The zeros are -2, +1, and then set this one equal to 0 would be -3/2. And again, you can check it out. I'm going to go to Desmos this time. Let's type in the equation 2x cubed plus 5x squared minus x and a -6. And look at that. Desmos is even nicer. So look at, there's the 1, 0, -2, 0. Here's the other one, -1.5, which is equivalent to -3/2. And here's the other 0, 1, 0. And you write it in a factored form. We have it all written in the factor form. We have all of our zeros. And you show it with synthetic division. It's just so easy. All right. Sorry, I could do this stuff forever, which I do.